We can also use trigonometry to determine angles. If you think of the examples we've done so far leading up to our SOHCAHTOA, right? I gave you the angle, I gave you a side, I asked you for the other side. But what if I give you two sides and I ask you for the angle? So what we got here is we got 4 centimeters, we got 3.5 centimeters, and we've got an angle there. Color code, and you can see that we've got the opposite and the adjacent. So means that we use the sine. So sine theta, opposite over hypotenuse, 3.5 over 4. 3.5 over 4 is 0.875. So what we've got to solve here is sine of theta is 0.875. In other words, what angle has a sine of 0.875? Now, the way that we used to do this was extremely arduous. The way you do it now is you have a little calculator button that says sine to the minus 1. So you just take the sine to the minus 1, the inverse sine, or the fancy way of saying it is the arc sine of 0.875. It's theta. In other words, the angle that has a sine of 0.875, and theta turns out to be 61 degrees. Wasn't that jolly nice? Let's do another. Again, here's an angle F, just for fun. Let's make up some other numbers. And I've given you two lengths. Which lengths have I given you? Well, I've given you the opposite, which is 7, and the adjacent, which is 6. So, therefore, if I'm using opposite and adjacent, that's the TOA, so tan F is opposite of adjacent, equals 7 over 6, which is 1.17. So what angle has a tangent of 1.17? Well, the one that has an arc tangent or an inverse tangent of 1.17, which is 49.5.